Welcome back to Code with DeepShook, and in today's video I'm going to be training two machine learning models that are classification models, which are logistic regression and decision tree. I'm going to use these models to predict a person's annual income, to see if it's less than or equal to 50,000 or greater than equal to that $50,000 based on their features such as age, education, occupation, and other dynamic factors. So first, what I did is I loaded my data set, my adult income data set into Panda, and then I Panda data frame, and then I assigned the column names, because if we look at the data set, these don't have names, so we wouldn't know if that's age or if if it's education and etc. So that's why I assigned names for the columns, and then importing my libraries, read from the data set, and then we seeing the first 5 rows, seeing the shape, and then looking at the data type to see what we're working with, what kind of information that we're working with. And then I also have replaced the missing values with the question mark. And then after that, I checked which columns have missing values, and then after that removed the rows that have missing values, and then recheck the shape. So, and then with that being said, I'm gonna comment this out. Oh, sorry about that. Sorry. I'm going to comment the rest of the code out, and then we're gonna check for missing values and clean up the data before we start training the data, the model. I'm sorry. Okay, so now I'm gonna run the code. Okay, so as we can see here, these are the five first rows, and then we can see we have about 15 columns, and this is how much values that we have. Yeah, and then this, as you guys can see, we have signed the columns some name. We have named the columns right here, and then as we can see, we have all type data type. We have a string and integers types. And then if we look at word class, we have this. That's how much missing values that we have, and this is how much we have for occupation, and native country, this is how much we have. So, and then I believe this is after, let me check if I ran that. And this is how much values that we have after removing the missing values. So yeah. Okay, so I'm going to uncomment the rest of the code out again, so we can work with the code, so we can train the model. Okay, so now, so now what I did, after cleaning the data, I prepare for machine learning. And then since the model can't work with direct text, I've used label encoding to convert the text columns like working class, education, occupation, and occupation into numerical values, into numbers, and then right here, that's what this is for, this right here. And then I've used I use standard scanner to standardize the numerical columns like age, education, so that they would like all be like set in on the similar scale. And then like, so yeah, and this is something that we've seen before. So yeah, with that being said, once the data was prepared, I separated into like futures from the target value, and then I input the future and store in X, as you guys can see that, right there. And then so while the income columns became a target value stored in Y right here, after stored in Y, so after that I used the select KBIS for with the ANOVA FIS test to select the 10 most important information. This allows the model to like focus on the features that have the strongest relationship with the target. So yeah, so with that being said, I then splitted the data set into training and testing data using so using like I split it into like, so using like 80% of the data to train, and then 20% for testing. So yeah, that's what I did. And then after that, we trained the first model. So after training the first model, which is logistic regression, I made prediction. We made a prediction on the testing data, and then like evaluated performance using accuracy, and then like confusion matrix, persistent recall, and F1 score. The logistic regression method achieves like accuracy of like about like 80%. So, and that's something that we're gonna see when I run the code. So, but first I want to go through the code, and we can run it together and see it and analyze the data together. After that, I trained the decision tree classifier using the same training and testing data set. I evaluated using the same matrix, and the decision tree performed like, that's something that we will see later, like to see how we performed based, like we're gonna compare the two to see how well they performed. So after I trained the decision tree, I use GridSearchCV to like improve the decision tree model. What this does, like it automatically tests the different combination of hyperparameter. So like including maximum in-depth of the tree, and the minimum number of samples required to split a node, and then after testing multiple combinations, we're gonna see how that's like. So like, yeah, so let's run the code and see how that looks like. Let's actually delete that and then rerun it again. Okay, so this is the regression model. So as we can see right here, this is its prediction. So like less than 50,000. So this is how much it got correct, and this is how much it got wrong. And then like greater than, this is how much it got correct, and this is how much it got wrong. Okay, so, and then this is the decision tree. I'm gonna look at the data real quick. So we already looked at that. And then the missing data, we can see it has like it has turned all the data type into int, and that's what we did, and that's what we want. And then this is the prediction. Let me see. Yeah, so these are the prediction. Let's go back to, and then this is the classification. As we can see right here, in some parts it performed better than the regression, in a lot of parts actually. So yeah, so with that being said, and then this is like the decision tree when it's like when it like enhanced, and we can see that it performed like way more better by itself, but before it was enhanced. So yeah, so basically that's my video, and that's the video for today. Thank you so much for watching, and you guys have a good one. Thank you.